Hello everybody. In this lesson we will discuss different types of exponential equations and how to solve them. You will learn to recognize what kind of equation it is and which method to apply. So let's go ahead and take a look at the first type. Here you see that we have the following question: solve each exponential equation, and in this case we will have the same base on each side of the equation. Whenever that happens, that's probably one of the simplest types. All we have to do is set up the exponents equal to each other. So in this case, we would say 2x plus 1 is equal to 3. And now we solve for x. Okay, so from here, this is 2x is equal to 2. So x is equal to 1. And we can always check our work by plugging this back in. So this would be 3 raised to the power 2 times 1 plus 1. That is 3 to the third power, which is exactly the right side of the equation. Okay, let's take a look at the next example. Here I have 5 raised to the power 2 minus x equals to 5 raised to the power 7x. Once again, I have the same base, so we set our exponents equal to each other. Okay, we get a simple exponential, nope, not exponential, linear equation. So this is equivalent to 2 equal to 8x, or x is equal to 2 over 8, which reduces to 1/4. Okay, and of course you can check. If we plug this back in, this is 5 raised to the power 2 minus 1/4, which is 5 raised to the power 1 and 3/4. Okay, and then 5 raised to the power 7 times 1/4, that is 5 raised to the power 1 and 3/4. It's the same fraction. Okay, so that works out. And then let's take a look at one more example. Here I have base 7. Okay, so I set my exponents equal to each other. Okay, we can clear our fractions here by multiplying everything by 6. So we get x minus 2 on the left, and on the right we get 3. So the final answer is x is equal to 5. Okay, let's go ahead and check this real quick. 7 raised to the power of 5 minus 2 over 6. What is that? This is 7 raised to the power of 3 over 6, not 2. Okay, and that of course reduces to 7 raised to the power of 1/2. All right, so this is our first example where we have equations given to us with the same base. Now let's take a look at the next set of problems. Here you will see we do not have the same base right away. We will need to rewrite our equations so that all powers have the same base. So we need to do one extra step here to convert these equations to the first type. Okay, let's take a look at the first example. We have 4 raised to the power of 2x minus 3 is equal to 64. So this is equivalent to 4 raised to the power of 2x minus 3 is equal to 4 raised to the third power. From here, this is 2x minus 3 is equal to 3, and easy to solve. Okay, x is equal to 3. And of course, you can check if you would like. Okay, let's see, that's 4 raised to the power of 2 times 3 minus 3. That's 4 cubed, which is 64. So this works. All right, let's take a look at the next example. Here I have 9 to the x is equal to 1 over third root of 3. So I'm going to rewrite my 9 as 3 squared and then raised to the x. And this power right here, what would that be? This is 3 raised to the power negative 1/3. Okay, so from here we get our exponents to x equal to -1/3. Okay, so from here x is equal to -1/6. All right, okay. Let's take a look at one more example. Here I have 2 raised to the power 3x minus 1. 32 is fifth power of 2, right? So this is 2 to the 5. And now we just set our exponents equal to each other, okay, and solve for x. And in this case, we get x is equal to 2, okay? Let me go ahead and highlight our answers. So for the first one, we got 3, -6 for the second, and +2 for the third. All right, so we have two types so far where we have the same base right away. If not, inspect your equation and see if the numbers look like they could be of the same base. Okay, so then the last type is a little bit less intuitive. What do we do when we have numbers so that no matter which power with a nice integer power we take, we're not going to get these equal to each other, right? So 19 to the x is equal to 143. You can already see what's going on here. 143 is not a power of 19, right? So how do we deal with equations of this type? So there's a trick here that we need to be aware of, and we need to take natural log or log of each side of the equation. And you'll see that we will be applying the power rule for logs to solve these equations, and most of the time the answers that we're going to get are not going to be nice integer or fractions. They will be decimals, so we will need a calculator to approximate these answers. Okay, so that is our trick here. Take natural log or log base 10 of each side of the equation. So let's go ahead and solve these problems. Okay, let's see. For the first one, I have 19 raised to the power of x is equal to 143. So if I take natural log of each side, what's going to happen? Remember the power rule. We can bring that x down, and that is the main goal, to bring that down so we can solve for x. Okay, so I brought it up front as a coefficient. Now, natural log of 19 and natural log of 143, those are just numbers. They're not nice numbers, right? So keep that in mind, but they're just numbers. There's nothing scary about them. We can solve for x here by dividing. So this is natural log of 143 divide by natural log of 19, and roughly approximated, I'm going to get 1.6855 as my answer. And how would you check here? Okay, I would plug this in into my calculator. So let's say 19, if I raise it to the power 1.6855, I'm going to get approximately 143. I'm not going to get exactly 143 because of the rounding, okay? But we will get a number very, very close to this one. All right. So could you also take an log, regular log here? Yes, you could just also take log base 10. Okay. All right. So that's how we solve a problem of this type. Now let's take a look at the next two problems. Now let me go ahead and copy these. I'm going to need a little bit more room. Okay, so problem B, I have 4 raised to the power x plus 1 is equal to 6 to the power of x. Okay, remember our goal. Our goal is solve for x, right? So we're going to use that trick and take natural log of each side. Natural log of 4 raised to the power x plus 1 is equal to natural log of 6 raised to the power x. Now I'm going to bring my coefficients down, or my powers, bring them down as coefficients. So this would be x plus 1 times natural log of 4 is equal to x times natural log of 6. Now I'm going to distribute everything on the left. This is x times natural log of 4 plus natural log of 4 is equal to x times natural log of 6. Okay. Next step, I'm going to bring everything that has x to one side. Okay, it doesn't matter which side, so I'm going to put it on the left. So x times natural log of 4 minus x times natural log of 6 is equal to natural log of 4. This should be a minus, right? Minus natural log of 4. Okay. All right, now what? I'm going to factor out the x. That was the whole reason why we brought everything that has x on one side. And now we have our answer. Okay, x is equal to negative natural log of 4 divided by natural log of 4 minus natural log of 6. Okay, so that's how we get this exact expression for x. Okay, so let me go ahead and highlight it. This is exact, right? Okay, now of course we're going to use approximation. We would like to see what that number is. So using your calculator, you would say x is equal to approximately 3.4190. Okay, and we can always check this. So if I were to plug in 4 raised to the power x plus 1, so that would be 4.4190. It's approximately equal to 6 to the power 3.4190. Okay, now, of course, because of the rounding error, you're not going to get exactly the same values, but it will be very, very close. So that's one way we can check if we've solved this equation correctly. Okay, all right. Now let's go ahead and do one more example of this type. And this one right here. Okay. Part C, problem C, we have 5 raised to the power x minus 3 equals to 13 raised to the power x plus 2. Again, I'm looking at these bases, 5 and 13. There's no way to rewrite this equation such that I have the same base. Okay, so I'm going to take natural log of each side. Same trick as before. Right, now I'm going to bring my exponents up front as coefficients. So this is x minus 3 times natural log of 5 equals to x plus 2 times natural log of 13. Okay, we multiply everything through, so x times natural log of 5 minus 3 times natural log of 5 equals to x times natural log of 13 plus 2 natural log of 13. Okay, just like before, I'm looking for my terms containing x. I'm going to isolate them on one side. Let's do the left side for x. Everything else is going to go on the right side. Okay. All right, now we're going to factor x. Natural log of 5 minus natural log of 13, that's inside. This expression doesn't change, right? And the last step is to divide to solve for x. Okay, so we get 2 natural log of 13 plus 3 natural log of 5. Okay, divide by natural log of 5 minus natural log of 13. Okay, that's our exact answer. Approximately, we would plug this into our calculator and we will get negative 10.4219. Okay, all right, we can check this. Let's go ahead and check this real quick with the calculator. So if I were to plug this in, so 5 raised to the power negative 10.4219 minus 3 and 13 raised to the power negative 10.4219 plus 2. Okay, in each case, I'm going to get a small number. Okay, what you're going to get if you plug this into your calculator, something that says like this, 4.15427 times, it will say e to the negative 10, which is really just 10 to the negative 10. So that's a very small number here. Similarly, you're going to get 4.15413 raised to the power, oh, times 10 to the negative 10, which is just a scientific notation for these really small numbers. Okay, and you can see that up until this point right here, they're exactly the same, but because of the rounding error, we get slight difference. Again, I don't want you to be too concerned about it. This happens because we're rounding, right? But this is a nice way to check if you've computed your answer correctly. Okay, so let's go ahead and take a look at what we've done here. We talked about exponential equations with the same base. That's our easy case, right? Then the second case is if we have to rewrite equations to make them have the same base. And then the last one where we don't have the same base and there's not much we can do to make it. Okay, same base. So in this case, we're going to take log or natural log of each side, and then we do some algebraic manipulations to solve for x. Thank you for watching.